Okay, let's look at the homework 5, problem number 8. Alright, so we want to prove the sum of all these cosines is equal to this expression, and the sum of all these sine is going to give you that expression. Right, so we can kind of work on these at the same time. Right, so instead of looking at the sine and cosine, we can probably look at the exponential function, corresponding exponential function. For example, instead of cosine of theta, sine of theta, we can look at e to the I theta, right? Because cosine is just the real part of this guy, and the sine theta is the imaginary part of this guy, right? So for A, you're looking at the real part, right? Then sine, you probably need to look at the imaginary part of it, right? Then the second term is going to be e to the I 3 theta, right? Plus e to the I 5 theta, and so on. Right, then you have e to the I 2n minus 1 theta. All right, then you can see that this is the partial sum of a geometric series, right? So where A is going to be, and A is just the first term, so it's easy to find, e to the I theta, just the first term. Right, R, you can see that every time you go to the next term, you are multiplying by e to the I 2 theta, right? You can see that from here to there, you're multiplying by e to the I 2 theta, right? So that's going to be the R value. So it's going to be e to the I 2 theta, all right? So using the partial sum of the geometric series, so we know that this is going to be, right, so e to the I theta times quantity 1 minus e to the I, let's see, so it's going to be r to the, so it's going to be 2n theta, right? Divide the whole thing by 1 minus r, which is going to be e to the I 2 theta. All right. Then just like the example we did in optics in class, we can rewrite this guy as, let's see, let's try to see if we can rewrite. I'm going to go down here. So we have 1 minus e to the I 2n theta, right? So first thing we do is we're going to factor out e to the in theta, right? That way you would have e to the negative I n theta minus e to the I n theta, right? And then another thing we need to do is I'm going to factor out the negative sign. So I'm going to put the negative sign in front. All right, then you have e to the I n theta. All right, then I'm gonna just put a fraction. So I'm gonna put all right. So since we factor out the negative sign, this becomes negative e to the negative I n theta. All right, so negative sign is factored out, so it's going to be e to the I n theta. All right. So the reason why I wrote it as a fraction form is that this is almost the definition of sine n theta, all we need is here, we need that 2i on the bottom, right? So we can't just divide by 2i, so we're going to have to multiply by 2i, so we don't change anything here, right? Then you can see that here, this guy right here is exactly the same thing as sine of n theta, right? So we can write this guy as negative 2i e to the I n theta. Then you have a sine of n theta. All right, and using the same trick, we can simplify 1 minus e to the I 2 theta. So 1 minus e to the I 2 theta. So all you really have to do is plug in n equals 1 into this formula. So n equals 1 here, so it's gonna be negative 2i, right, e to the I theta, and you have a sine of theta, right? So you end up getting this guy right here, right? So you have e to the I theta, right? Then you have negative 2i e to the I n theta sine of n theta, right, divided by negative 2i e to the I theta sine of theta. All right, then we can cancel things out. So you can cancel negative 2i, negative 2i, and actually there's e to the I theta here, and there's a e to the I theta there, right? So what you get is, let's see, I'm gonna group this guy together. This has no I in it, so this is just a real number here. So that's going to be sine of n theta, sine of n theta over sine of theta, right? Then you have e to the I n theta, right? Then you can see that this guy right here, right? So this is the sum of these exponential functions, right? Exponential expressions, right? Then what you want to do is you want to find the real part of this guy to get the sum of the part A, right? And take the imaginary part of this guy to find the part B, right? Remember that we can use Euler's formula to split that into cosine of n theta plus I sine of n theta. Maybe I'll write that. So this guy right here is by Euler's formula, same as cosine of n theta plus I sine of n theta, right? So take the real part. Then here you don't get exactly this, but you have to use trig identity to simplify it to this expression, right? Then the imaginary part is exactly this, so you can easily get to that, right? That's it. I hope that this will get you going.